This video here follows on really nicely from the previous one on multiplication, except this time we're dividing terms in algebra. Now what that means is that I'm still going to be writing things out in long form and dealing with powers or exponents. However, when we divide things, we actually write them out as a fraction, and parts of those fractions are actually going to cancel out, as you'll see in a moment. These two problems here need to be simplified. So we're going to write them out in long form, and whenever we see a division sign, like this one here, we're going to write them out as a fraction. Now the reason is that a fraction and division, they're the same thing. I mean, if we look at 2/3, for example, that's exactly the same as 2 divided by 3. It's just written a slightly different way. So I can write this one as a slightly different way as 12 times x all over 4. It's the same problem. Now, when we divide, we need to treat coefficients and variables separately. So that means I'm going to divide the 12 by 4, but not the x by 4. So what I'm left with now is 12 divided by 4, cancel those out, and I'm left with just 3. Now that's still being multiplied by x, so I'll write the rest of the problem in, and then of course that gives me 3x fully simplified. The next problem, writing out in long form, we have 6 times y cubed all over 3 times y. Now with 3y, there actually is a power here, we just don't write it in. The power is going to be 1. When you have a power of 1, nothing really changes. It's not like y squared where you multiply it by itself. It's just y to the power of 1. Nothing really changes here. So that means we don't actually write it in, although it is still there. So when we actually go through and do this, I'm going to divide the 6 by the 3 to be left with 2. And then I'm going to divide my variables next. Term by term, I'll cancel out anything that's there. So we have y squared left over. Now there is actually a shortcut to doing this. What I can do is simply divide my coefficients to give me 2. And then when I have my power here, I can actually just subtract those two powers to also give me a power of 2. So that's the shortcut method for division simplification. Let's write these ones out in long form and see if the shortcut method might work. So here we have x times itself 5 times, all over x squared. So cancelling out objects that are on the top and the bottom of the fraction, term by term, I can see that I've got nothing left on the bottom of the fraction, so I don't write it. And on the top, I'm left with just x cubed. Similarly, with the second problem, we actually don't need to write this out in long form. Let's try our shortcut method and see if it works. I'm going to divide my two coefficients to give me 2, and then I'm going to subtract my two powers to give me x to the power of 4. Now you can write this out in long form yourself and see that you do actually get the same answer by cancelling out these terms. With the last one, I am going to write it out in long form because it's a little bit trickier than the previous problems. So there's the numerator of my fraction, already quite complicated. And there's the denominator. So let's just cancel out these terms, coefficients first, and then each variable separately. Cancelling out the 6 and the 2 gives me 3. Cancelling out the x's gives me an x remaining on the top of the fraction. However, with the y's, cancelling these out, you'll see that I'm still left with 1y and it's on the bottom of the fraction. So instead of being 3xy, it's actually going to be 3x divided by y because the remaining variable is still on the bottom, so it still has to be written as a fraction as 3x over y. And that's it. Thanks for watching.